Okay, before we start talking about the interesting stuff, let's quickly have an overview about the absolute basics. And I want to start with the concept of syntax, because I might use that word and also it's just an important concept. So basically, VEX is just another programming language, as you know. So for example, there's C++, PHP, Python, Mel, which is the Maya language, and then there's also JavaScript, for example. And the word programming language is actually pretty good because it describes one important concept. You can express the same thing in multiple languages. It's just that the words are slightly different that you use for it. So the logic very often is the same, which means when you already know a little bit about programming, then it will be very easy to learn VEX. It will take you very little time. But when you learn VEX as your first programming language, then just keep in mind that you're not wasting anything on purely learning VEX, but a lot of the concepts you learn there are true for almost all other programming languages. So for example, when we look at this overview here, you will find that certain things repeat themselves. So the data type string comes up in every single programming language. Also, the concept of a for loop that we will talk about comes up in every single language. And this program, by the way, just spits out 100 lines of text. And the comment concept is actually always the same. So the way it works in VEX is the same as in PHP or C++ or Mel. The only big exception usually is Python because it has a very special syntax. But syntax here, as you can see, basically just means the grammar of the language. And one of the things that you will see in VEX, which is the same, is that you have to finish a line with a semicolon and that you have those weird swirly brackets. And all of this is not a VEX thing really, it's a thing that almost every programming language has. And just keep that in mind. The rules you learn in VEX are not really VEX rules, they're programming rules. And with that said, one site in the help I would recommend is the Using VEX Expressions, which is kind of the introduction. And in here you will find really everything you need to start and a lot of things we've already seen here. So definitely give that a try. Of course, I've linked it on the site, but let's now jump in and let's start with the most basic stuff so that we kind of have this out of the way. The first thing, of course, so we have to have some geometry that we run over. And as we know, it's important to understand that there are multiple wrangles and they all deal with different elements of a geometry. But it looks more than it actually is because most of them are attribute wrangles. And you can switch to run over primitives, points, and vertices. You can also run over numbers. What that means is that this code will run a couple of times. So for example, 10 times. And then you have detail, which means, and we will see that later, that basically since there's only one detail slot for a geometry or for a stream of data, basically, you will only run this once. And this can be interesting, for example, when you generate geometry, because you can actually this way run a wrangle without any input. But we will look at this later. Let's start with the most common case, and that is that you run over the points. And very important, keep that in mind. We will talk about this more later on. Every single code you write in here will run for every single point separately. So if I have 100 points, then the code I write in here will be run 100 times. Very important. Then we know that we can access attributes, for example, CD, by just using the @ and then the name of the attribute. And let's fill this with something like 0. And if I do this, it doesn't work because I have to finish a line with a semicolon. That's just the grammar of the programming language and almost every programming language except Python. So this is the so-called syntax. Now, as you can see, I can turn the color to 0, which is just black. And I could also set it to 2, which is overly bright. And let's have a look what this means. Interesting enough, this means it creates a vector. For RGB, it fills in the 2, and that is because CD is usually a vector. And what I would always recommend is that you add the data type in front. For a vector, that would be V, for an integer I, for a float F, for a string S, and so on. And there are a couple more for more exotic data types like a matrix, and you can actually read that here in the Using VEX Expressions, because here there is an overview, here it is, for the syntax of the data type before the @. Then, as you know, you cannot only write into attributes, you can also read out attributes. for example, P, which is the position. And here we do something that very barely makes any sense, but I like it nonetheless, because now the position becomes the color. And that means if I move my grid around, the color is changing, which is just cool. So this shows we can read and write at the same time, but I could also set a vector, and we usually do this with set, because then we can actually, in this case, we only use numbers, but we could, by using the set function, we could fill in those numbers with other functions. And this is why I just make a habit of always using set to set vectors. So here we can see we can set red with 1, 0, 0, but we can also do something funky like using the current frame. And with that, I want to talk quickly about those magic attributes. And those are, for example, frame. And here, by the way, I used a comment so that this is not actually considered code. So you can see it turns yellow because with the 2 dashes, I can say, look, this isn't code. This is for human to be read. And if I want more than one line, I can do this. And again, the cool thing about this is not a Vex rule. This is true for C++, JavaScript, PHP, and also Mel. So many different languages use this logic. And here I can keep going. So for example, we've seen that there is a magic attribute called frame, and there's also a magic attribute called time. By the way, frame is including subframes. So you can have frame 11.5, for example, if you have subframes in simulations, for example. And time is the time since the start of the scene in seconds. And all of this you can actually find again in the use Vex expressions down here. A couple of more are there as well. Where is it? Here it is. And then you have also sim time. So if you're inside of your DOP network, for example, your time may start, your simulation may start at a later frame, then the sim time is relative to that, and same for sim frame. And then there's time inc, which is the increment per subframe if you need that. So what happens if I put the current frame into the color? Well, this happens. It goes brighter with every frame, as you can see down here, which currently doesn't make too much sense because it's, you know, the frame. So maybe a bit more sense would actually make time in seconds. And then you can see you can make something start to glow. Let's actually put it on real time. There you go. And then it starts to glow. And just with those magic attributes and the attributes you already have, you can actually do quite a lot. Because if you bring in the most basic control function, the if function, then you can test things for certain cases. So for example, if the current frame is higher than 24, let's say, then, you know, we've already seen a very helpful function to kill the current point. And that means nothing happens until frame 24, and then it kills each point. A bit more interesting is when you do this with ptnum, not higher than 24, but you can actually say if the point number is higher than frame, or actually smaller than frame, there you go, then you can do this. You just delete the point that is smaller than what the current frame number is, and then you can do, you know, funky stuff like this, which is especially funny when you do this with a more complex geometry with more points as well. So this might be a bit slow, so let's speed this up by just multiplying this by 5, let's say. Actually make this even faster than that, 25 maybe. And here we go. Based on the point number, stuff now disappears. As you can see, since you have no control about the point number, this is completely kind of unpredictable, even though it's kind of funny. And by the way, that also works for curves, even if I use an ugly curve like a draw curve, because a curve has points and primitives as well. You can do the same thing for a curve, which is then interesting and maybe a bit too fast this time, because you can this way, you know, delete a curve without using a carve node. So this is kind of interesting, using the point number for this. Let's get rid of this. So let's try something else. Instead of the point number, let's use the position in Y, and let's do this with a time. And here you can see you can implement a very simple disappearing effect from the bottom. So as you can see, it doesn't need much to, you know, do interesting things with Vex. You need to be able to read out attributes. You need to know about a couple of magic attributes like time and frame and ptnum, an if statement and a remove point, and you can do already quite a lot. Talking about ptnum, and let's put this into a comment again, we have ptnum, and this gives you the current point number. Then you have numpt, which is funny because it's just, the two elements turned around. And this gives you the number of all the points in your geometry. So in this case, that would be 12,874. And if you want to do the whole thing not with points, but with primitives, you can, instead of removing the point, also remove the primitive. And then the only difference here is when we quickly look into the help, that it has 3 inputs, geohandle and primitive number, of course, and then end points. And the question here is, should it delete the points or not, or should it keep them intact? So if I say 1 for yes, basically, then, and also it shouldn't be ptnum, but primnum, which I wanted to show you with this, then you can delete the same for the primitives. And this is actually what I wanted to show you. The primnum is the same for the current primitive number. And therefore, there's also a numprim, which is the number of all prims. And let's quickly try what happens if I set this to 0. Then the faces are deleted, or the primitives, but the points are staying intact. And then finally, of course, you can also use stuff like random based on the point number, like this, or you can use noise. This usually doesn't use a point number as an input, but of course a position. And in case you want to have directions, which doesn't make too much sense here, but let's say we put this on the normals, then you can use a curl noise. And this is of course something we will talk again in the next couple of videos, because I want to go a bit deeper into this topic. But those are the most important things. Maybe one last thing, and that is internal variables that I almost forgot. So if I put a noise into the color, I can also at the same time change the position, maybe with a plus. And to make sure that I don't have to deform both things, actually let's use only the Y element, that I don't have to change 2 things. If it's actually the same, I can just put this into an internal variable like n. And I have to declare this by saying, okay, in this case, it's a vector that is filled by a noise. And this means this is internal variable. The syntax is a little bit different, no at in front, but the name of the data type right before written out. And then this n will never come out of my wrangle, but stays inside. And this is usually useful for reusing stuff. So for example, if I want to change the size of my noise, I can change it for both and not just one, because the result is saved in n. Okay, so I think there shouldn't be anything new for you. All of this should be known. If not, maybe watch the VEX videos in the basics chapter again. But with all this as a base, we will move into more complex things next. So I hope this is helpful. Thanks very much and see you later. Cheers.